Hi everyone, this is Hemant from Team HAYYat. Our problem statement ID is 1719, that is monitoring system for classroom session in skill training program. So our problem statement goes as, in a skill development training program, we will be given the image of the classroom, and using those images we need to tell whether the skill development program is efficient or not. So it helps the institution or the organization to get insights about the training program beforehand, wasting more amount of time and money on the skill development training programs. To solve the given problem statement, we are going with the solution of computer vision. So in our solution, when the classroom images are given to us, first we will detect the student body posture, indicating that how attentive the student in class, and other metrics like eye gaze detection, which direction the student is seeing, whether he is seeing towards the board or outside of the class. So using the lip movement, we would tell how the student is participating and interacting with the class and teacher. And using the head position, we can tell that whether the student is looking straight to the teacher or bending his head down or moving his head sideways to talk with his friends. So based on the measures and indications we have taken, we will consider different metrics such as student engagement levels, teacher-student interactions, and how well the student is performing in the class using the images. And based on these, we will make a decision system where we will calculate the metrics of every student in entire class and develop a scoring algorithm to determine the effectiveness of entire class. So we will use the algorithm to flag classrooms as low engagement or poor interactions for further monitoring or actions. So if you see our prototype, here we have the direct image of a class, and using the OpenCV libraries and dlib modules, we will detect different face points of students. So here you can see how we will be detecting the face markings of different students in entire class. So based on these points, we will detect how every student is looking, whether they are looking straight to the teacher or they're looking away from the class. So here you can see that this is the original image on your left side, and after detecting that, you can see that there are different photos where the student looks sideways. So here you can see that a woman looks sideways, and our metrics based on the points difference between the cheek and head positions, we can say that how the head position of students are related. So here you can see that using the body position, we can tell whether the student is sitting straight in the class or moving his body away, or he is sleeping in the classroom. Here you can see that using the posture detection algorithms, we can detect the posture of each student in the class. So if every student is sitting in the class like this, then the class is effective. Or if any student is sleeping like this, or standing, or playing with mobile phone, then we can tell that the classroom is inefficient. So here you can see that how well our posture detection is making the assumptions. Here you can see that the students are on the table, and we can easily tell that the students are standing. Here, based on the positions on the head and eye, we can tell that this woman on the left side is looking sideways, not straight to the teacher. So here you can see that based on the body detection and mouth and lip movement, we can tell that whether the student is talking or yawning. Here you can detect that using body posture and face recognition algorithms. So these are some prototypes where even we have a different number of students, we can detect their faces and analyze their emotions. So you can see like this, we can detect their emotions. Based on these key points and mappings, we will calculate the difference between their eyes, nose, mouth to detect their facial recognition and also how they are interacting with the class. So here also you can see that if there are number of students in the class even, we can detect their faces and even their facial expressions, their eyebrows, their nostrils, their lip movements, and even their engaging with the class or not. So here are some of the examples. Even the image is very blurry and which contains very noise also. Our face detection algorithms can easily detect the faces and analyze the emotions, face patterns there. So here you can see that we are also detecting the eye gaze as the woman here is looking straight forward here. So the points we plotted are different from the left and right images. The distance between the points can be calculated easily to detect which direction the eyes are placed. So using these metrics, facial recognition algorithms and body postures, we can tell that whether the training program is being effective or not in a classroom. Here we also developed a web application for the institution where the university can track the classes and their efficiency day by day. So here you can see the schedules on day 1, 2, 3 and 4. So if you just click on this, you will just see that what are the sessions subjects of that class. So on the 1st September we have these subjects to be conducted to the class. So if you just want to go deep into the insights of this class performance, you can just click here. So you will get a statistical report how the performance of class is being maintained. Here you can see the intensity of the class at different hours. So you can actually tell that at the starting of the class, the intensity of students listening and performing in the class will be very high, and gradually as the time goes it will be decreasing. So here you can see that we also provided how the class looks like at the maximum intensity and minimum intensity. So at the maximum intensity you can see that the students are looking at the teacher and performing, they're talking with the teacher, they're interacting with the teacher. But at the minimum efficiency you can see that students are talking to each other, they're sleeping, they're just not looking at the teacher or they're not reading. So we also gathered this information. So if you just want to go for the other subject also, you can find that the statistical report and how the student looks at when the class is at maximum intensity. You can see that every student is listening to the class, and if the class is at minimum intensity you can see that the students are not just listening to class, they're just playing. So this is our prototype, and here you can also check how well the schedules are conducted. I mean, like the entire class report, you can see that. So here you can see that at different classes, the intensity of students. At the first class, the intensity at 0, and the second class, the intensity at high, and gradually as the day goes and the class passes, at different classes, the intensity of student drops down as the day ends. So using the web application for an institution, we are also giving an entire view of how a class performs in different sessions, and we will be doing it with the help of computer vision, face expression detection, posture detection, and other computer vision algorithms. Thank you.